Welcome back to Everything Learning. I'm your host, Wonye Collins. In today's video, we'll be converting decimal to binary in relation to bits. So in our last video, we spoke about data representation, where I explained what bits and bytes is all about. So in this video, I'll show you how to convert a decimal to a binary, but in this formula, with this particular method of which I came up with, I refer to it as the dash method. So let me just put that down. Dash method. So this method is way more easier and so on. So first we'll talk about decimals. So let's say we're given a number 234. So we're going to start from the rightmost part of the number to give each number its own term. So the four we have here, refer to them as the ones place. Then we have the 3 as the tens place. Then we have the 2 as the hundreds place. So what do I mean by this? So we have 4 times 1, which is same thing as 4 times 10 raised to the power of 0, which is equals to 4, because 10 raised to the power of 0 is just 1. Then we have this as 3 times 10 is equals to 3 times 10 raised to the power of 1. We have this as 30. Then we have this as 2 times 10. We have it as 2 times 10 raised to the power of 2 is equals to 200. So when you sum this up, you should be having 234. So moving on, in this dash method, it's way more easier to use dash method to convert decimals to binary. So first, you have to know the type of the number you're working with. So the number, we call them title number. So that title number is what you're being asked to convert this title number. Title number. So let's say we're given a series of title number. Let's say we have 17. So let's say this A, we have B, we have 50, we have C, we have let's say 9, we have C, and we have D, we have let's say 130. So we've been asked to convert all of these to binary, but now we're going to do this in relation to bits. So first, for the first one, which is 17. So now, in bits, I told you guys earlier that you can just save one number in a bit, but in a byte you can save 8. So since you're working with 17, I'm dealing with binary numbers. Using this format here, which is just to the power of 2, 1, and 0, we can draw 4-1, 2, 3, and then 4. So the first one here, we'll multiply it by 1, which is 2 times 1, which is going to give you 1 times 1, we'll have 1. Then we have here going to be 2. Multiply this by 2, will give you 4. Multiply this, will give you 8. And we can add another one. 8 times 2 will give you 16. So since the number after 16 when multiplied by 2 is 32, we don't actually need this 32, because in your binary number you do not start with a 0, you actually start with a 1. So this 16 now, so the way we solve this is by using this 17 to go into all this, and then we solve. So first, is 17 greater than 16? If yes, you write down 1, then you subtract this from this. Subtracting this from this is going to give you 1. You're going to have a remainder, and the remainder is 1. Is 1 greater than 8? No. Is 1 greater than 4? No. Is 1 greater than 2? No. Is 1 greater than 1? No. It's actually equal to. So since it's equal to, it's not going to be 1 minus 1, it's going to give you 0. But since it's equal to, we're going to still use that same 1 for it. So for the B part, we'll be using a fresh page. So the title number here is 50. So I'm going to use 4 rules to explain this particular question. In other ways, it's going to make it more understandable for anyone that is currently finding it difficult to answer that first question. So in this second part, first, remember I told you guys are going to draw down your dash. 1, 2, 3, 4. But how do you know the number of dashes that you need to draw? So first is that when you're dealing with a number above 16, you're going to draw 8 dashes. If you're dealing with a number below 16, you're going to draw 4 dashes. Why do I say so? If for instance we're having 50, okay, let me say I'm going to draw 5 right now. So we have 1, 2, 3, 4, 5. So you write down 1 multiplied by 2. When you multiply this by 2 again, which is 4. Multiply this by 2 again, which is 8. Multiply this by 2 again, which is 16. Multiply this by 50 is above 16. So let me use the 8. Let me use the 8. So we have 1, 2, 3, 4, 5, 6, 7, 8. So we have 1 multiplied by 2, we have 2. Multiply this, we have 4. Multiply this, we have 8. Multiply this, we have 16. Multiply this, we have 32. Multiply this, we have 64. Multiply this, we have 128. So you have 128. The first step after doing this is that you take the title number and compare it to your decimal number here, or your binary conversion number. So we have 50. Is 50 greater than 128? If it's greater, you write 1, then you subtract. But if it's not greater, you write 0 and then you move to the next number. So 50 is not greater than 128, so write 0. Is 50 greater than 64? No, so write 0. Is 50 greater than 32? Yes. You write down 1, and you do 50 minus 32. So 50 minus 32 should give you 18. So you have remainder 18. So is 18 greater than 16? Yes. Write down 1. Then you subtract 18 from 16, which is going to give you 2. Is 2 greater than 8? No. Is 2 greater than 4? No. Is 2 greater than 2? It's equivalent, it's equal to. Since it's equal to, another rule, since it's equal to, you will subtract from it and write 1. So when you write 1, you do 2 minus 2. 2 minus 2, you're going to have remainder 0. Is 0 greater than 1? No. So this is the binary number. Binary number for 50, and convert it. So in data representation in computer, these are represented this way. But in normal binary system, you could mostly, it will start from this 1. It doesn't have this 0 behind it. But since we are dealing with bits and bytes, and we know that 8 bits make 1 byte, that's why I included these last 2 to make this a complete byte. So we have 1, 2, 3, 4, 5, 6, 7, 8 bits, making the total of 1 byte. So moving on to the next title number C, which is 9. So for 9 now, is 16 greater than 9? Yes. So we just need just 4. So we have 1, 2, 3, 4. So we have 1, we have 2, then we have 4, then we have 8. So now, if we should include the 16 here now, we're going to have 0 because 16 is greater than 9. And if you don't want to use the full 8 bits, you can use 4 bits. That's half of a byte. So now is 8 Is 9 greater than 8? Yes. You write down 1, then you do 9 minus 8. It's going to give you 1 as your remainder. Is 1 greater than 4? No. Is 1 greater than 2? No. Is 1 greater than 1? Is equivalent to, that's equal to 1. So you're going to do a minus 1 minus 1 is going to give you remainder 0. So you're going to write down 1 here. Remember, if it's equal to, you write 1 and then you have remainder 0. Then move to the next, which is D. For D, we're going to ask you, dozen number is 130. So for 130, we're going to look at, okay, 128 is for 8 bits, that's 128. And the next is actually a greater number, it's going to give us 0, so we don't need it. So just what we just need is just 8 bits, 8 dashes. So we have 1, 2, 3, 4, 5, 6, 7, 8. So we have 1 multiplied by 2, 2 multiplied by 2, 4 multiplied by 2, 8 multiplied by 2, 16 multiplied by 2, 32 multiplied by 2, 64 multiplied by 2, 128. So is 130 bigger than 128? Yes, it's bigger than this. So you're going to write down 1, then you subtract 130 minus 128. It's going to give you remainder 2. Is 2 greater than 64? No. Is 2 greater than 32? No. Is 2 greater than 16? No. Is 2 greater than 8? No. Is 2 greater than 4? No. Is 2 greater than 1? Is equal to 1. It's equal to 2, sorry. So it's 2 equal to 2. Then you subtract 2 minus 2. It's going to give you remainder 0. Then you write down 1. Remember, if it's equal to, you write 1. Then now, is 0 greater than 1? No. Write down 0. And then we move on. So there is this point I want to point out, that if you notice, when you come to 9, as a prime number, as an odd number, let me use an odd number, they always end with the ones. So you could have 3, 7, 9, what else? 11. They are all going to have the ones placed at the end. So we're all going to have 1 at the end, 1 at the end, 1 at the end, 1 at the end. So in case you missed my last video on data representation, I'll drop the link so you can check out the video. And if you have any other question, you maybe come up with a confusion or something, please do have to drop it in the comment section. I will reply to every comment, and if I have to make another video to make more clarity or make an emphasis on something or any of the questions I answered, I'm going to do that for you guys. Thank you so much, and stay blessed.